We are going to start our session about architecture for an IoT pipeline delivering real-time analytics here at Data Innovation Summit. My name is Gregor Bauer and I'm VP Customer Engineering at CrateDB. So first of all, let's get started with what is CrateDB. So we're an open source company founded in Europe and fully in Europe with offices in Vienna, in Munich, and Dornbirn in Austria. We are on GitHub. We have 7 million downloads in the community clusters worldwide running. And we were built by a team of different data experts in the market. So this is what we came together, trusted by enterprise customers all over the world. So what is Crate? We have a very flexible data model. We basically store everything in a table, but additionally you can store inside also JSON, time series data, full text, vectors, geospatial data, and blobs. The schema is completely dynamic, so that means you don't need any schema change. Everything can be dynamic. Every row you insert can be dynamic and be a combination or just types of what you see below. We can do real-time user-defined functions. So we are a very quick, very flexible database, and you can define your functions which then give you results in real time when you need it. Additionally, we also have integrations for CDC, so change data capture, or foreign data wrappers, which allow us to basically get the data from other databases to combine it into a single view, for example. We are completely distributed, so not like traditional databases. We actually have a distributed storage engine. So we store the data in different nodes. So this also enables us to have high volume concurrent read and writes. The query engine is also distributed. So really the best of both worlds. Everything distributed for querying, and we store it. The storage itself is columnar. So that means we don't have traditional tables. The tables are basically flipped by 90 degrees. So that means, for example, ad-hoc queries for aggregations like min, max, and average are extremely fast because the database doesn't need to be scanned row by row. It's one column where everything is inside, which we can then have, for example, temperature, min, max, which we're also going to show later on. And of course, implemented high availability and horizontal scalability. We have different deployment models. We believe strongly that the source needs to be the same everywhere. So for us, there is no difference if you deploy on an edge location as small as a Raspberry Pi, or having hybrid scenarios where you have edge, something close to the edge, and something in private or public clouds. All of them can sync data and combine the data into a single source and also talk to each other, sync to each other. The best part also, we are having a native SQL interface. So that's a Postgres interface. That means everything you have as connectors where Postgres is written on it, you can use that to connect to Crate. So that's a huge advantage and gives us a very large ecosystem we can integrate into. Speaking of integrations and ecosystem, this is typically the data we're dealing with. So enterprise data might come from ERP, MES, asset management, often in the IoT space, telemetry data, sensor data, streams, and so on. But also unstructured data, PDFs, images, maintenance data, tickets, reports, and external data, market data, stock information, or weather data, which we're going to show later. So the connectors itself use then different protocols, for example, edge protocols like OPC-UA, MQTT, Modbus, and many others. Then we can also leverage streams like Kafka or Talend and so on. But also ETL and batch processes is possible to load large files, for example. For AI, also embedding multimodal algorithms is possible, and we have also a large tech ecosystem in all kinds of systems like Crosser.io, CoreFlux, Hive, MQ, Node-RED, and many others, which are integrated into Crate ecosystem or are even built on top of Crate. So what applications are we then fueling with? So end-use applications, real-time analytics, data science and visualization, predictions, recommendations, natural language applications, AI, ML ops, LLM ops, data governance. What does it give us? Hindsight, so analyze historical information. Insight, where we can analyze the current events, real-time analytics. And also foresight to predict with the information we have also the future. So which challenges does Crate solve? Limits on scalability. As I said, we are a completely distributed database, so we have unlimited linear scalability. Insights not in real time. Another challenge we solve, because of the distributed query engine, we can ad-hoc query large data sets in milliseconds. Problem like exponential rising data volumes, we tackle with scale in and scale out. Also, we can have cold, warm, and hot storage separated on different data tiers to save money on the actual provisioning of it. Decentralized siloed data. We have a vast variety of data types, so that gives us the possibility to have really a 365 overview of data, meaning many different sources can be combined in a single source to display it and make it available to make cross silo queries in a single database, and that's great. Augmented increased productivity, as we also support AI by multimodal and vector support. You can do your RAG applications, also your MCP integrations for your AI. And then you have the data available in real time and also 365 overviews over all your data being centralized in Crate. Planning and operational costs, we lower the footprint because of the architecture and because it's linear scalable, we can actually save costs because it's very fast, so you can do more with less actually compared to other systems. So perfect fit for multiple needs. So if you think about Crate, keep in mind these use cases: Internet of Things, time series, digital twins, real-time analytics, AI and agentic for real-time needs, ML and QA applications, OEE, database consolidation, log analysis, geospatial tracking, predictions, recommendations, and to speed up complex SQL queries or any other data-intensive project. So now for the demo part, we're going to talk a little bit about time series. So where is the problem with time series? It's everywhere. So all kinds of devices and everything you use day by day creates time series data. Might be tracking, might be logs. Even on your mobile phone, there's logs, which is typically in time series. What's the challenge? Keeping up with it. Most people actually store that, but the handling of these high ingest, because it's so many time series data, is challenging. Also, reading the data immediately after it's written, another challenge, because then you would not query fresh information when you have it in a moment when it arrives, but maybe only later on. So it's old data. So keeping up with the load high ingest rates, immediate querying after writing, and fresh information. This is usually the problems and challenges in time series data. Because if you work on old data, maybe lost opportunity, in worst case, also waste you produce in a production setup, when you might have a stopped production line, worst case. So then the demo architecture we're going to show today is a simple sensor creating architecture, which generates weather data, so temperature data, wind speed, and humidity. And this is what you see here. So that's the data producing part. We're going to use a fixed data set, which we have from the European Union. So that's real-time or real-life temperature data from last year, which will be streamed then to a managed Kubernetes, managed Kafka service. And these events are then serverless being read, and then in batches written to Crate. So this is this part. So benefit, of course, it's very lightweight. So we stream the data and only process the data when they come in. We batch write it to Crate. So, and then we read it on a Grafana dashboard in real time. So ingesting data while reading it to make real-time insights into our data. If you'd like to try it out, you can do that. github.com create real-time demo if you like to try it yourself. As I said, the producer part, it's a binary file of this Copernicus project. It's historic data of temperature readings from the whole world. Everyone can download this and play around with it. It's mostly for researchers, for prediction models. We use it to ingest like real-time sensor readings. The code is quite simple. We load the data, we sequentialize it, we put it into a JSON format, and then load it into the managed Kafka service on AWS. How does the data look like? Raw, it's similar to this. So basically, temperature 2 meters above reading, then a timestamp and a type. It translates to actually this. So it's a Unix timestamp, latitude, longitude, where it was actually read, and then the temperature reading. So the consumer part, this is our Lambda function. So it's serverless to very lightweight pick data and pick events when they appear. And in the end, it just reads the data, does a little bit of transformation, and then raw inserts it via SQL and our HTTP endpoint into CrateDB. Consumer code, very simple. We just need the connection details here. We create the connectivity and then load the raw SQL statement into Crate. So what does the SQL statement look like? For the information I showed you before, it's basically this. And here you can already see the advantage of CrateDB, because we have a single statement inserting data, but we combine multiple information in a single query. This is the timestamp. So we have table data, we have geospatial data, which is in an array here, and we have JSON data. Everything can be added on the fly for you don't need to do any schema change. It's super flexible and allows us to add multiple sensor data constantly from different sources. Even they can look completely different, and just ingest these data. On the other side, we have a user interface, which is a Grafana dashboard in our case, which shows the data flowing in. So it reads live from the database. Also, the aggregations will be done in real time, for example, min, max, and average temperatures, all with our standard SQL interface. So from Postgres, we just use the standard Postgres compatibility connector, which reads then directly from Crate. So let's run the demo. So here we have our dashboard actually. So it's empty. And what I'm going to start is now the producer. So what it will do, as I said, it will read the data, what we have, and then create it as a stream, connect to the managed Kafka service, and then send in batch these data. And here you can see them flowing in already. So we have a refresh rate of 5 seconds. That's the limitation of Grafana. But if I refresh more often, you can actually see what I mean with real-time data. You can see the data flowing in from, for example, here northern Germany to southern Germany. You can see the heat wave coming in because it's readings from summer last year in August, where the temperatures quickly changed over time. Here you can see from 1 hour to the other that the data is changing. The other cool thing is basically the aggregations we do here ad-hoc. So this is not pre-aggregated. This is not done on the Lambda service. It's basically calculated and done by the database itself. It's a min, max, average, and even more calculation statement, which then shows us the graphs in real time, what is happening with the data I'm looking at. So huge advantage to get real-time insights of the data you have in your systems. Could be sensor data, could be temperature readings, could also be logs or trading data, whatever. Insights in real time on the data. So a few other examples, for example, here you see basically the statements, what we see in the background, what is actually done by Grafana. So we have the latitude, longitude data, temperature reading from a database. And here you see already how we combine the different elements for querying. So table data with geolocation and the JSON. So JSON is very natively, just like in Python, when you have your dictionary to query the data from. So I'm going to execute that. And here you see how it's represented. It's in a table format, time, latitude, longitude, and the temperature. Let's have a look at some other examples. So the min-max values, as I said, are calculated in real time by the database. Of course, as we are having a columnar storage, this makes it easy to very quickly ad hoc do these aggregations. For example, here min-max average of our time. A little bit more complex calculations what we do. You can do min-max on top of a calculation. For example, for the wind direction, we have 2 dimensions we need to combine as a vector into a vector speed. That's what we do here with square root. And then we do min-max average over all of our calculations. So that's also what you see here at hoc. Another example is what we can do even with polygons. So as you saw, we have all over Germany our lat long points spread all over it. We are just having this query, but you can also select certain areas only and use our polygon search. So for example, if you have a city or a county which you want to select, you can also do that. You can see here our normal select statement and where the location is within that actual polygon. Here we have our search with Polygon. As before, we see here the normal query with select, timestamp, latitude, longitude data, and we select basically in which polygon it should be out of our complete data what you saw before. and see if it's within. So this data is within, and we limit it to 10 and then just display this one. So this you can do geofencing, for example, or query certain areas and even aggregate over areas as everyone needs. Okay, so we have done the demo. Closing remarks from my side. If you want to learn more, there is the CrateDB Academy. There is courses available for time series, advanced time series, and also architecture. The location for this would be learn.cratedb.com, and you can also try our cloud for free. So there is a free trial, and you can reach it by console.cratedb.cloud. It's free forever. You can play around with it, with your data sets. It's quite powerful. What we also would always be grateful for is if you would leave us a reference. You can also do that on g2.com. Very happy if you would love to do that. And that's also it from my side. You can ask me anything. This is basically the QR code. You can book a meeting with me, or you contact me over LinkedIn if you like, and you can also drop me a mail if you like. Thanks for tuning in. See you soon.